complex numbers. What are they? So basically, if you have two real numbers, let A and B be real numbers, then A plus BI is a complex number. A plus BI is a complex number. Like it says in the line above, A and B are real numbers. The A is called the real part, and the BI is called, or the plus ABI is called the imaginary part. So we want to write the following numbers, or we want to identify the real part and the imaginary part of these numbers. 7 plus 3i, say negative 2 plus 3i, 13 minus 7i, 13, negative 8i, and say negative 3i plus 9. Well, it's clear as day, this is in the form of A plus BI. So that's the real part, and this 3i is the imaginary part, IP. A number plus a number I. That's the real part. That's the imaginary part. Now, I claim that that's the real part, and that's, including the minus sign, is the imaginary part. And this is correct because anytime you like, first of all, realize that that 7i is plus 7i. Anytime you like, you can change those two signs, and you'll get 13 plus negative 7i. That's the real part, and that's the imaginary part, just like I said over here. Now, just understand that you can, for 13, understand you can always add 0. Anytime you want, you can add 0. In this case, I want to add 0i. Okay, that's the real part. 0i is the imaginary part. Negative 8i is 0 minus 8i. The real part is 0, and the imaginary part is negative 8i. Now, addition commutes. This is 9 plus 3i. That's the real part. That's the imaginary part. You could have said from up here, that's the imaginary part, and the 9 is the real part. Nice and simple. Now, we give you some complex numbers. I'm going to ask, we want to write the following in A plus BI form. Write the following in A plus BI form. And this time, I'm going to suggest being very rigorous or demand that you be rigorous in writing it in the form of a plus bi. So, if you have 3 minus 7i, this is 3. Understand that that 7 is positive, and that's the subtraction sign. I can change both of them. A plus bi. A is 3, b is negative 7. The square root of negative 3. This is the same as negative 3 is the same as 3 times negative 1. If you have a product underneath the square root sign and they're not both negative, you could separate them. The square root of 3 is the square root of 3. The square root of negative 1 is I. So this is 0 plus the square root of 3i. A plus bi. If you have the square root of negative 16, this is the square root of 16 times the square root of negative 1. That's the square root of 16 times the square root of negative 1 is I. So this is 0 plus 4i. You can always add 0. So a plus bi. A is 0, b is 4. Now, if you notice, this minus sign pretty much just comes out as I. So if you have the square root of negative 25, this is just the square root of 25 times I, better known as 5i, also as 0 plus 5i. What if you were asked to write the following in a plus bi form? Suppose you have the square root of 2 plus the square root of negative 7. Well, the square root of 2 I can't do anything to, plus the square root of negative 7, well, that's the square root of 7i. And I don't know the square root of 2, I don't know the square root of 7. But I do know that it's in a plus bi form. Matches up perfectly. Now, if you have 3 minus 4i, and you want to add 8 plus 6i, just add the real parts and add the imaginary parts. I mean, you can just think of I as a variable, if you like. That is, you add like terms. 3 plus 8, 11. Negative 4i plus 6i is plus 2i. A plus bi. Perfect. Now, how about 5 times 2 minus 3i? 5 times 2 is 10. Minus 5 times 3i, well, 5 times 3 is 15, times I. Ooh, that's a minus bi. Now, usually when they say write in a plus bi form, they also allow a minus bi form. So, unless otherwise stated, this answer is in a plus bi form. But I did state that I want it rigorously written in a plus bi form. That is, I want the plus between the a and the b. So this is 10 plus. You can change that to addition as long as you change the sign of the 15i. there is no sign, which there isn't, is understood to be positive. So I make it negative 15i. A plus bi. Try some more. You have 2 times 2i plus 4. Well, 2 times 2 is 4 times I, plus 2 times 4 is 8. Now, this is not in A plus bi form. Addition commutes. Now it's A plus bi. A is some number, plus is the addition symbol, b is some number, and I is the symbol for the square root of negative 1. This result is in A plus bi form. How about I squared? Well, this means I times I. Well, I don't know what that is, so let me go back to definitions. I is the square root of negative 1 times I, the square root of negative 1. That equals negative 1. Just like the square root of 7. The square root of 7, by definition, is that special number that when I multiply it by itself gives me 7. For example, this is going to be wrong, but it'll make it clear. The square root of 7, let's make believe it's 2.3. Now, the square root of 7 equals 2.3 since 2.3 times 2.3 is 7. But you know what? 2.3 is the square root of 7 times 2.3, that's the square root of 7, equals 7. Oh, you mean if I multiply this number by itself, I get what's under the radical? Yes. By definition, the square, probably a better way of saying it is, let me actually do that. Let's call the exact value of square root of 7 k. The reason the square root of 7 equals k is because k times k equals 7. But another way of writing k is square root of 7. Another way of writing that k is square root of 7. Oh, look at that. The square root of 7 times the square root of 7 is 7. The square root of negative 1 times the square root of negative 1 is negative 1. Now, I want, you know how earlier I said if you have 6 times negative 1 each under the square root sign, it becomes this? In fact, I actually said it the other way. That is, you can write, let me actually do it. Hold on, please. The square root of negative 6, well, negative 6 is 6 times negative 1, and I'm taking the square root of them. Now, as long as both of these are not negative, you can take the square roots separately. You can take the square roots separately. And this gives you the square root, the square root of 6i. Okay. So, let's look at the line above. Now, notice that because equal goes both ways, if this left box equals the right box, then the right box equals the left box. That is, if you have the square root of one number times the square root of another number, you can multiply the numbers and then take the square root. Oh, I understand now. I could take the square root of -1 times -1, which is the square root of 1, which is 1. Oh, but wait a minute. I didn't get the same answer. That is correct, because you cannot, if you have this, you cannot go here. That is, I agree that this is the square root of 1, which is 1. But I do not agree that it equals this. Because, as I said very clearly, you can break up 6 times -1 into the product of the square roots, because not both of these numbers are negative. 6 is not negative. Both of these numbers are negative. So you can't do that. That is the square root of I times I, which is the square root of -1 times the square root of -1, is not the square root of -1 times the square root of -1. If both of these are negative, you can't separate them. If both of these are negative, you can't combine them. This is the square root of 1, which is 1. Okay? This is not 1, because if both of these are negative, you can't multiply them together to get 1. You can only do that if at most one of the numbers are negative. Can't stress that enough. Now, what if you have 3 minus 5i and you want to multiply by 2 plus 7i? Well, just distribute. 3 times 2 is 6. 3 times positive 7i is plus 21i. Negative 5 times 2 is negative 10i. And negative 5i times 7i, well, a positive times a negative is negative. 5 times 7 is 35. I times I is I squared. So we have 6. And if you want to combine these now, it's 11i minus 35 I squared. But I squared is negative 1. So you get 6 plus 11i plus 35. You get 45 plus 11i. I squared is negative 1. If you were asked to multiply negative 2i plus 3 by 11 minus 3i. This is the 11 is understood to be positive. A negative times a positive is negative. 2 times 11 is 22 times I. You multiply those two. A negative times a negative is a positive. 2 times 3 is 6. I times I is I squared. If you want to, you can put negative 1 right away. A positive times a positive is a positive. 3 times 11. A positive times a negative is a negative. 3 times 3 times I. So you have negative 22i plus 6 times negative 1, because I squared is negative 1, plus 33 minus 9i. That's negative 6. And when you add you have positive negative 6. So you have 22i. I can change and change. So you take away 6 plus 33 minus 9i. 33 minus 6, or if you insist, negative 6 plus 33 is 27. If you take away 22i, then you take away 9 more, you took away 31i. That's the answer to that problem. Okay, let us look at this. Suppose you have a plus bi, and you multiply by its conjugate, a minus bi. Now, since these numbers are complex numbers, we call them complex conjugates. That is, a complex conjugate of a plus bi is a minus bi. A times a is a squared. Remember, a is positive because there's no sign. Positive times negative is negative. A times b times I. Plus a times b times I. Minus b times b times I times I. So if you take away this, whatever it is, and you add it back, it's gone. So you have a squared minus b squared times I squared, which is negative 1. That is, you have a squared plus b squared. Oh, you mean when you multiply complex conjugates, you get the first squared plus the second squared. You get this squared plus that squared. Or if you prefer, this squared plus that squared. And that formula is quite helpful. Because if I give you 7 plus 3i, and I ask you to multiply it by its complex conjugate, which is 7 minus 3i, remember that's a and that's b. Ooh, I get 7 squared plus b squared. Done. 58. That was easy. 3 minus 4i times its complex conjugate. That's a minus bi, a plus bi. According to our formula, we're just supposed to get a squared plus b squared. 3 squared plus 4 squared. 25. Oh, when you multiply complex conjugates, as this answer shows, you get a real number, because there's no i's in it. Just a real number. And actually, the timing for that was pretty good, because now we can look at division. Suppose you have 7 plus 2i over 3 plus 4i. Now, this clearly equals itself times 1. There's many ways of writing 1. And I should say that we want to write this in a plus bi form. That is, we don't want to have a complex number in the denominator. So you know what? I'm going to multiply the denominator by its complex conjugate. Because then the denominator will just be 3 squared plus 4 squared. It'll just be 25. Now, if what's in this bracket has any hopes of being 1, whatever I put on the bottom, I have to put on the top. So you have 7 times 3, which is 21. 4i, excuse me. This product will be minus 28i. This product will be 6i. That's a 2. And then the last product will be positive 2i times negative 4i, which will be negative 8i squared. So we have 21 minus 28i plus 6i, and this will become plus 8 because I squared is negative 1. So it's plus 8. And you add the real parts in the numerator, you get 29. You add the complex parts, which are those two, and you get negative 22i all over 25. Now, generally that's fine, but I did say write it in a plus bi form. And I'll lax the fact that that has to be plus. A plus bi form is also a minus bi form. Now, let's look at the following. Any number including I to the 0 is 1. And I to the 1, well, that's I. And I squared, well, we talked about that, that's negative I. And I cubed, well, that's I squared times I. Well, negative 1 times I is negative I. That's important. Now, I to the 4th, well, that's I squared times I squared. That's negative 1 times negative 1, which is 1. Now, I to the 5th, well, that's I to the 4th times I. I to the 4th is 1 times I is I. I to the 6th, that's I to the 4th times I squared. I to the 4th is 1, and I squared, according to this table, or if we remember, it's negative 1. I to the 7 is I to the 4th times I cubed. But I to the 4th is 1. Well, that is, this is just I cubed. But according to the table to the left, that's negative 1. Now, oh, okay. No, that's negative I. And I'm an idiot. 1 times negative 1 is not negative I. It's negative 1. If you notice, we got the exact same answers as we did here. 1, I, negative 1, negative I. You get the same answers. For example, if I were to ask you what I to the 97 is, well, notice that 4 goes into 97, 24 times remainder 1. That is, 97 is 24 times 4 plus 1. It's 27 times 4 plus 1. Well, let me write the 4 first, not that it matters. It's 4 times 24, excuse me. 4 times 24 plus 1. Now, this is the same as I to the 4th to the 24th, because you multiply them times I to the 1. Because you add the 1. Remember, if you have A to the B to the C times A to the D, well, this first part is A to the BC times A to the D. Bases are the same. Add the exponents. Now, here's where things really get neat. I to the 4th is 1. So you get 1 to the 24th times I to the 1, which is just I to the 1, which is I. If you were asked what I to the 203 is, well, 203 is 4 times 50, which is 200. plus 3. I claim the answer is I cubed. This is I to the 4th to the 50 times I cubed. But what's in here is 1, and 1 to the 50 is 1. And 1 times I cubed is I cubed. And I cubed is negative I. Okay, so basically, if you remember these here in this first box, you're okay. If I ask you what I to the 500 is, well, it turns out that 500 is 4 times 125. It is 4 times 125. No remainder. So this is I to the 4th to the 125. But I to the 4th is 1. Raised to the 125 is 1. So if you multiply I by itself 500 times, you'll get 1. If you multiply I by itself 203 times, you'll get negative I. This completes the section on complex numbers.